Welcome, friends. In this video, we're going to be going over how to graph trigonometric functions, which are sine and cosine functions. It starts with a unit circle. Plain and simple, when you rotate something, it's going to create a periodic function. Let's take a look at an example. All right, let's take a look at this circular motion here. Now, I really want to just focus on right now the y values. So if you're at 0 degrees on a unit circle, then as you rotate around counterclockwise, and that degree measure goes higher, the y value gets higher as well. In fact, the highest value that y goes on the unit circle is 1. And as you keep rotating around the circle, it oscillates between 0 and 1. And then at 180, which is also pi radians, it's going to be back down to 0. That y value continues now in the negative direction. And so at 270 degrees or 3 pi over 2, it's now negative 1. And then finally, when it does one full rotation, it gets back up to 0, which one rotation on the unit circle is 360 degrees, but we also think of it as 2 pi. That's called the sine function. So the sine of x is literally all the y values from the unit circle modeled over the angle. And you can do the same thing with the cosine function as well. Let me go back to the 0 again. So at 0 degrees, cosine is actually at 1. If you look at the x value here, that's at 1. Remember, the radius of the unit circle is 1. And as you go through the circle, here the x value, when it's at the y-axis, is 0. So it goes down to 0 here. Halfway around the circle at pi, or 180 degrees, now it's down to the negative ones. And then it repeats itself over and over again until you get something like this. And these go on forever. So you can keep that going on. It'll go past 4 pi. It'll go in the negatives. And if you put them together, they're basically the same type of graph, just one shifted over. Here are those two graphs again with all the extra circle fluff. And as you can see here, if I isolate one, the cosine function tends to start at the maximum value. When I say start, I mean at the y-axis. And then it keeps going down, 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 and then until it hits its maximum again. And then it keeps going over in both directions. If I limit it to just one rotation around the unit circle, we have what's called a period. A period is when the x value it takes until it repeats itself again. In this case, the period is 6.28, which is 2 pi, because that's one full rotation around a circle. We can do the same thing with sine. Notice that the sine function starts at the middle at 0 instead of at 1. And it keeps repeating itself over and over again. And then it repeats itself here, not at the max, but at the middle value. In fact, 2 pi is going to be one full rotation. If I limit it to, like I just did on my cosine, you can see that that one period is going to be still 2 pi, but it's going to have more of an S shape rather than that bowl shape. And if you put them together, it's just one's out of phase with the other. So they're going to be the same type of graph, but the cosine is just going to start at the maximum, and the sine is just going to start at the minimum. Now we can make those graphs shift up, down, left, right. We can stretch them. And so this whole series of notes and examples is going to be talking about, well, what happens when you move the graph? Can we identify a few key features of them? So first, let's define what those key features are. They're very specific to sine and cosine graphs. We have what's called a period. And a period is a horizontal distance where the graph repeats itself. This is a sine function. And for a sine function, it's going to repeat itself by default a little bit after 6. That's one full rotation. That's in radians. So that's going to be 2 pi radians. So we call that our period. And how do I know it's 2 pi? Well, 2 pi is one full rotation around a circle, but also on this graph, you see that it repeats itself on the x-axis right here at 2 pi. Cosine does the same thing, except the difference is cosine starts at the max and repeats itself at the max. And so this period is going to be also 2 pi. Now, sine and cosine functions also have a midline. The default midline is always going to be the x-axis. We can shift that up or down. But for right now, that midline has to have an equation. So we say y equals 0. Y equals 0. That's the equation of the midline. Now, if I shift that up, down, left, up and down, I can change that midline to a different number. But the default is y equals 0. And finally, these all have what's called an amplitude. Think about like music. When you turn the volume up, that wave gets bigger and bigger, right? If you ever like look at a sound mixing board. So the amplitude represents basically how tall the graph is. But there's a catch. It's not the overall height. It's only half the height. We can think about the amplitude being how much it deviates away from the middle. So if you look at the middle here at 0, the amplitude's not negative, not 2, even though it does go from -1 to 1, we just count from the midline to the maximum value. And that default amplitude is going to be 1 for both of these. We can change that number. But to start, that's how you identify those features. So the period, 2 pi, amplitude 1, the equation of the midline, y equals 0. And now we can get into what happens when we shift these graphs. So we're going to do one example on this video. The other videos will cover the other examples. Let's take a look at an example. Well, what happens when the graph gets shifted? All right, in this case here, we have to be able to first look at this graph and identify what kind of graph is it. Now, if you look at where it starts, notice that it starts at the maximum value. Well, that's going to be a cosine. Any graph that starts at the maximum or min is going to be a cosine graph. If it starts at the midline, the middle value, it's going to be a sine graph. So we know it's going to be a cosine graph because it starts at the max. But notice that it doesn't have an amplitude of 1. It has an amplitude of 2. And notice that its midline is shifted downward. Let's try to put that all together here. So what I want to do is be able to identify from this graph the equation of the midline. So we first want to look at, can we find the very middle value? And if you look at the minimum value at -5 and the maximum value at -1, it looks like the middle value here is going to be -3. So when we're talking about our equation of a midline, I usually, especially if I have this graphed out, I'll draw a line here in the middle and I'll say y equals -3. Remember, it's a horizontal line, and to get a horizontal line, you need a y equals with it. So you must have y equals a number to accurately have the equation of the midline. Let's look at the maximum value. The maximum value you can get from the graph, and it's always a y value. So we're looking at y values here. In this case here, it is going to be -1. And then the minimum value is going to be -5. The amplitude is the distance between the midline and the max. It's not the overall distance. The overall distance is 4. But how far is it just from this value to here? Okay, that distance right there is between -1 and -3. Well, those count to 2. Okay, so your amplitude is going to equal 2. Amplitude is always going to be positive. So don't do, -3 or -1 minus 3 and -1. Just count the distance here, and that amplitude is going to be 2. So always positive. Now, is this sine or cosine? We've already identified it as cosine because it starts at the max. So we'll say cosine. Now let's figure out what that period is. So the period can change too. And how that changes is basically what number is going to be multiplied by the x in the function. So we'll put a graph together so you can see. The period is going to be this horizontal distance from the y-axis, from where it starts, until it repeats itself. So if I trace this graph, and well, here I have not repeated myself, but if I keep going, now we're all the way down at the bottom, which means we're halfway there. So we got to extend that to the next peak. And right here, right at that spot, notice that it's going to keep that pattern going. So this x value right here represents your period. And the reason it's an x value is because period represents a horizontal distance. So x is the horizontal axis. In this case here, it's 2 pi over 3. So now what we have to do is we have to figure out how to build a graph from this, okay? So take a moment to write all these down. And let's come up with the graph. We'll graph it in Desmos to make sure we're on the right page. So here's how it works in general. Okay, we've identified this as a cosine. So the first thing we're going to have is y equals some number, I don't know that number yet, so I'm going to leave it blank, times cosine. And then we're going to put an x right here, but there's going to be a number with that x. We'll have to calculate that. But then there's going to be a number at the end. Now I say plus, but if it's going down, it's going to be minus. Okay, so that's the general format for these. Now let's talk about how to get those values. So to begin, I start with my amplitude. My amplitude is always going to be the number that's going to represent that leading number. That's your stretching or compressing. Okay, so if we want to think about that 2 as stretched vertically, that's going to be this number right here. And that's just a multiplication. So you can literally type 2 cosine. Let's go to the end now. I saved the middle part for last because it's the hardest one. The end number is going to be what that equation of your midline is, except ignore the y. The y is kind of built into the equation, so you don't need it here. So this last number here is going to be -3. Now, I would rather you write -3 at the end as opposed to plus -3, but you can get that. Now, the way you get the number next to the x value represents your period. So to get that number, it's not just 2 pi over 3. You have to do a little bit of math to get the right number in there. So to get that number, you're going to do 2 pi divided by your period. So that looks like 2 pi divided by 2 pi over 3. Now you can use your calculator. You can do this by hand. I'll show you both ways. If I'm doing 2 pi divided by 2 pi over 3, it's really just kind of a keep, change, flip problem. 2 pi times 3 over 2 pi. And those 2 pi's will cancel out. And the number that you're left with in this case is just going to be 3. And so that's going to be the number attached to your x in there. So that would be your equation. Now, I know you probably don't believe me right now, so let's think about, actually what that looks like here. I'm going to need to write all this down, so pause the video and do that. I'm about to clear it off. Make sure that when you're graphing in your calculator, whether you're using Desmos or your TI-84 or another graphing calculator, you're in radian mode. So on Desmos, you click the wrench and you click radians. So the next thing you want to do is I want to compare it to y equals cosine of x. This is going to be your default graph. And since cosine is the type of graph we're looking at, that's what we're going to compare it to. So let's remember what we wrote. Remember our midline was going to be at -3. So if you do -3, notice that it shifted down at -3. But notice it only goes up to -2 and down to -4. So we're going to have to take that amplitude and stretch it a little bit. Since our amplitude was 2, we're going to put a 2 out there. Notice it got taller. Okay. So the last piece of the puzzle is messing around with that period. Now let me show you on the calculator too, that to get that number next to x, you can put any number you want. You put a 4 there, 3 there. It stretches it horizontally or compresses it horizontally, depending on the number you put. Now, if you leave it alone, that default period is 2 pi. So what you do is you do 2 pi divided by, and then since our period was identified as 2 pi over 3, notice that we ended up calculating 3. That's the number that's going to go right in there. And that is the graph that you see over here. Now, it's kind of hard to see there, so I'm going to make it a little bit smaller here. And I want to show you that if you look at that next peak here, it repeats itself at 2 pi over 3, which is exactly what this drawn graph does. So we have our minimum at -5, our max at -1. Our midline, you can even type y equals -3 to get that midline in there if you need to. And you can see that period is going to be equivalent to what's on here. All right, thank you for watching this video. The next video will go over the rest of this examples.